All right, this video here, finishing up our kind of discussion on empirical formulas. So we know that empirical formulas are the simplest whole number ratio, but there has to be some way to get from the empirical formula back to the molecular formula. So that's what we're going to talk about here. So a molecular formula tells us the actual number of atoms in one molecule of that compound. Or I guess it could be formula unit as well. And it's always some multiple. And sometimes that multiple is 1, 2, 3, 4, 5, 6, whatever. We just need to figure out what that multiple is. So to do this, to find the multiple, we need the mass of the molecular compound. So you have to be given the molecular mass. And then we're going to compare it to the mass of the empirical formula. So what that means is you need to calculate the empirical formula first, then find its molar mass, and compare it to the mass that you are given for the true compound. So in example 4, a compound has an empirical formula of this. So let's say we've already done the calculations, we've done the work, and we find our empirical formula to be this. We're then given the mass of the actual compound. We need to find the molecular formula. So what we need to do is we need to find the molar mass of our empirical formula. So what we know is we have carbon, we have hydrogen, and we have oxygen. So carbon has a molar mass of 12.01, and we have 2 carbons. We know hydrogen has a mass of 1.01, and we have 3 of them. And we know oxygen has a mass of 16.00, and we have 1 of them. So we do our math here and add all of this up. 12.01 times 2 plus 1.01 times 3 plus 16. We get a molar mass of our empirical formula as 43.05 grams per mole. That's for the empirical formula mass. The empirical formula molar mass. Well, we know it's some sort of ratio. It had to be reduced by something to get this empirical formula. Well, if we know the actual mass, which we have right here, we know what the reduced mass is, we can figure out how much we reduced it by. So all you do is simple division, 172 divided by that number you just calculated, 43.05, and then we're probably going to have to round here, but 172 divided by 43.05, I get 3.995 as my answer there. Well, that is approximately 4. So that's the ratio of how much we reduced it by. So we need to multiply this by 4 is what that tells us. So C, 8, H, 3 times 4 is 12, O, 1 times 4 is 4. That is my molecular formula, which is based off of that. Doesn't like my 4. Just based off of the ratio. So calculate the mass, compare it to the actual mass. That'll get you a ratio again. Multiply by that ratio to get the molecular formula. So that is how you do a problem like that. Sometimes though, as I said, you might have to do this calculation first, so it could be kind of a two-step problem. Part A might say calculate the empirical formula. Part B might say then find its molecular formula. In this case, we didn't have to do that; we were already given this. But it could be an A and then a B problem to get this.